In this lesson, we'll talk about the contrast example that we did in the previous lesson, but I'm going to show you how you can get the same results in JMP rather than calculating by hand. So again, this is the contrast example in JMP. So the question was, is there a difference between the mean texture readings of bologna made with different cognac blending levels? So we're going to compare the 0.5% to the 1%. It turns out that the first treatment combinations or mixtures have blending at 0.5% and the next six mixtures have it at the 1%. So if we're looking at this contrast, we could set up the hypotheses in this way, saying that there's no difference between the first six versus the next six, versus a contrast where we could actually subtract to look at it equal to 0 versus not equal to 0. So you can go through these screenshots and it'll show you the different ways of setting this up, but I'm going to go ahead and go through that with you in JMP. So if you look at how the data is set up here, you'll notice that, again, the first 6 combinations, so again, we've got up to 18 here because there's 3 replicates of that. We've got these first 6, which are with blend A, and the next 6, which are with, the 0.5% blend, and the next 6 that are with the 1% blend. So we want to look at the average of this group compared to the average of that group. We're going to come in and do just the regular ANOVA analysis. So analyze, fit, model. We put the mixture in as the response, and then the texture reading, the mixture in as the model effect, and then the texture reading in as the response. I will tell you that I like to relate this back to the model. So if you think about the model here, we would have y, I, j, right, is mu plus alpha I plus epsilon ij. In JMP, you don't have to put in the last error term. You don't have to put in the overall mean. You need to put in the response. That goes in right here, and then anything in here goes in your model effects dialog. So if I'm looking at this alpha I, those are the treatment effects. So that's why the mixture comes in here. Okay, so I always relate this back to the model, the effects model. So I'm going to run that. And you'll notice that down here, here's your ANOVA analysis. So again, we said before, we're going to reject the null hypothesis. It does seem like the mixture has an effect, but with contrast, we want to know what is that effect, and maybe we have a specific comparison we want to do, and that relates here to mixture. So I'm going to come here to mixture, and I'm going to go to LS means contrast. And so I said the first 6, so I'm going to hit the plus sign for the first 6, and you'll notice that JMP automatically calculates my contrast coefficients here. And then I'm going to hit the minus sign for the next 6. So that's going to do the exact comparison that I want to do. I'm going to hit done here. And you'll notice that here's your F statistic and here's your p-value. Now, we also talked about this in terms of the t-test. If I hit the arrow here, there's your test detail. So this is your, if you're looking at this, this is your L hat value right here. This is L hat. These are your CIs, right, your contrast coefficients. This is the standard error. This is your t observed value. This is your p-value, which again is the same p-value you see here. It's just giving it to you in more scientific notation. And then you'll notice here that this F statistic, if you took this 13.183, you square it, you're going to get that F test. So here we're testing the H naught L equal to 0 versus L not equal to 0. This p-value here and the p-value here, they're the same thing. They're for the two-sided test. If you wanted a one-sided test, you'd have to determine if you needed to divide that p-value by 2. Okay, so if you go back here, again, I have that output here in JMP. I'm telling you, you have to select the arrow to see the t-test. Our p-value is less than 0.0001. We reject, and we conclude that there is a difference between the texture readings of those made with the different cognac blending levels.